So hi and welcome. So can you hear me? Can you hear me? So we are waiting some 1 or 2 minutes, then we just continue our class. Okay, so we will start our today's class. And if anyone can miss the class, then they have also get the recorded class. Now can you see my screen? Can you see my screen now?
Yes, yes.
Okay. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. We already covered our fifth number of classes. So today is our sixth number of class. And today's course content will be that. So mainly from this class, I will try to discuss about the land use and land cover classification mapping using the different types of machine learning. It can be random forest, it can be classification and regression trees. Okay, so how you can easily use the machine learning method using Google Earth Engine platform and then make the land use and land cover classification map. And then we also try to make the land use land cover classification chart. In this time, we can also calculate the area and then we can get all of the area value and present in the chart. Okay, and finally, we also try to discuss about that how you can easily add the legend on your LULC map. Okay, so when you want to work with the land use land cover classification map using the Google Earth Engine platform, we just should know the some step. We need to follow the some step. So first of all, you need to selecting your ROI. So your ROI, it can be Dhaka city, it can be any area. Which area you want to make the LULC map? Okay. So first of all, you need to selecting your ROI. Suppose you want to make the land use land cover classification for the Dhaka city. So first of all, you need to import your shapefile, import your boundary shapefile in Google Earth Engine platform. Okay, and select your ROI. And final second step is that you need to choosing and filtering the image collection. If you want, you can use the Sentinel-2 satellite imagery. If you want, you can use the Landsat. So you need to choose and filter the image collection for your according to your time period, according the image properties. So all of the things you can filter and choose the image collection. After this, you also need to collecting the training point. So you can get the training points such as different types of classes. So because in this time we are using here the supervised machine learning method. So that's why first of all you need to collect the training point for which class you want to classify. Suppose in this time I want to classify the water body, then I take the training point for the water body. I want to take classify the urban. I want to take the training point for the urban. I want to classify the forest, so I also take the training point from the forest. Okay, so I collect the some training point. Okay, then fourth step is that I need to merge all of the training point. Okay, then I also make I from all of the training point I create the training data set. So in this time this training data set has stored the different band pixel value. Suppose first of all I also need to select the some prediction band. So I have to select the some band spectral value, and in this time when I want to merge all of the training point and make a training data set using this all of the merged training point. Okay, Then I also need to create the classifier. So there are the lot of classifier in available in Google Earth Engine platform. It can be random forest, it can be classification regression trees, and classify the image and create the classified image and display the result. Then I also need to work with the accuracy assessment. So for the accuracy assessment, I want to just work with the confusion matrix table. So for the accuracy assessment, I try to just work with the confusion matrix. Then using the confusion matrix, I try to calculate the overall accuracy of this map. And finally, we can also calculate the area of for each classes. So when you want to make the land use land cover classification map for any region using the any types of satellite images, it can be Landsat or Sentinel, doesn't matter. So all of the process will be same. We just follow the step by step and then try to make the land use land cover classification map. Okay, so let's go. So I just simply open my code editor and try to show you the practically, then you can easily understand. So I simply open my code editor. I simply open a new code editor. Okay, so in this time, first of all, I need to select my region. So suppose in this time I want to work with the region of Dhaka city. So I just simply import the shapefile of Dhaka city. So I already import the shapefile in the asset. So I simply click on here. Now my Dhaka city is imported in my code editor. I simply change the name. Suppose I put the name is that ROI. You can use any name. I want to show the my area, which area I want to make the land use land cover classification map. I just simply use there the map dot add here, and then try to object is the ROI, and also add here the map object. Object is the ROI, and okay, so now I can get my area. Suppose in this time, this region, I want to make the land use land cover classification map and classified the water body, urban, forest, and barren land. Okay, so in this time, my first step is the done. I select my region. In this time, my second step is that you need to choosing and filtering the image collection. So it can be Landsat image or it can be Sentinel image. So I already show you that both of image how you can easily filter. So in this time, I want to work with the Landsat image, then try to filter this. Okay, so I simply go to the browse data catalog and find out my data set. So I want to work with the Landsat. I simply click on the Landsat, and I want to work with suppose all of the images the same process when you want to work. So I simply work with the Landsat 8. And then I simply go on the top of atmospheric images. I will just copy the artisan snippet from here and then simply paste in my code editor. And I simply put a variable name. Suppose variable name is that LA. Okay. So in this time, this image collection I want to filter according to the region, according to the time period, according to the image properties. Okay. So in this time, I just filter it. So I already discussed about this code, how you can easily filter. I simply take a variable name image, call the image collection LA, then simply use here the filter bounds function. So now it intersecting with the whole collection with my region of interest. So I simply put my region of interest is that ROI, and then I simply use here the another thing is that suppose filter date. Suppose I want to make the land use land cover classification map for year of 2020. So I simply put the filter date and then put here the time period, suppose 2020 1st January from 2020 December 31. So in this time, I just simply filter the image properties also. So I simply use here the filter metadata. and then I simply use this cloud cover that says less than 1. So in this time, if you want, you can easily work with the single image. You can check how many images available in here. So you can simply use the print and copy the image and paste here and click to the run. You can get all of the information about this all of for your region. So here you can see you can get all of the images. Problem. It counts ROI 2020. It's showing the 0 image. Why? Cover. Cloud cover less than 1. It's problem. Cover. Why is so okay? So I simply is wrong spelling in here. The cover. Okay, so I can get total 7 images in this region. Suppose you want to work with the any single image, you want to classify the single image. Okay, so you can get all of the image specific time period. You can see we already covered this part. Which image you want to need, you can simply just click on here and copy this image id. Okay, and take a variable suppose I take the variable is that, suppose I put the variable name is that img, and use at the ee dot yes, and then you can simply paste this id. Okay, so now you can work with only for the single image. Okay, so now suppose you want to also classify the single image, or if you want you can also create the median composite and classify also this image. So both of process is the same. So when you want to work with the single image, just simply copy this id from here and store this image in this variable. Okay, then your process your image filtering or choosing process done. Okay, so in this time I want to create the median composite and classify the image, but if you want you can also use the single image for classified. Okay, so when you want to take the single image, you can simply copy this image id and take a variable and then use at the e.image, then paste this, then you can easily work with the single image. Okay, so in this time I want to create the all of the images median composite and then classify the image. The both process is the same. Okay, so just I simply remove this, and then I simply all of the images I create the median composite and also clip my shapefile. So I simply use at the clip with my shapefile is that RY. Okay, so I simply show the image. So I simply use at the map dot add layer and call the object name is that image. And then click the run. So now you can get this satellite images for the Dhaka city year of 2020. We can get the satellite image look like this. In this time I also add the visualization. So I want to use the true color composite. So I simply click to here and then add here the suppose red band, green band and blue band. Here is the true color composite and stress 90%, then click to the apply. So now I can check. I get this satellite image. Okay, and I want to use the satellite image for making the land use land cover classification map for this region. So my second step is done. So first step is the selecting your ROI. Second step, you need to choose your image collection. It can be Landsat or Sentinel. Then you can filter this Landsat or Sentinel according to your boundary, according to your time period, according to your image properties. Okay, and then get the satellite images like this. So in this time, I follow the third step. Third step is that I need to collect the training point from these satellite images for which class I want to classify. Suppose I want to classify the water body, then I take the training point for from the water body. I want to collect classify the urban or build up area. Then I also take the training point from the build up area. Okay, Suppose I want to classify the vegetation, so then I take the training point for the vegetation. Okay, so in this time I just try to show you this process, so how I can easily do this. So for this, okay, so I also import the visualization in here. You can see it will be imported. I simply copy and paste after the object name, because all time we are put the visualization parameter after object name, object variable. So this is my object, and I simply put this. If you want, you can also add here the layer name, suppose true color or true color composite. So now you can see we can get this satellite images, and from this satellite images we need to collect the some training point, okay, which you want to classify. Okay, so in this time I want to just classify these satellite images and take the training point. Okay, so for the training point, in this time we are using here this marker tool. If you want, you can also use here the draw rectangle and take the training point pixel value. So mainly in this time we are getting the training point for extracting the pixel value of different types of band. Okay, all of the bands I also add later. So first of all I simply add the training point. Okay, and then I extract the band pixel value from this training point. Okay, so first of all I take the training point for the water body. So I simply click on the marker and then click on this setting button. Then I simply just put the name, suppose water. Okay, and then I simply take the geometry and feature collection. Okay, then property, you can use any name. Property, it can be any name, but property name will be same for all of the classes. Okay, so in this time I simply put the property name as a, suppose class. You can use any name, then no problem. Then I simply put at the value. I set the value for water is 0. Okay, then okay. Now you can see water. So in this time I simply click on the water. Now you can see it will be bold letter, black color. I simply select here and then take the training point from the water body. So in this time, in this place, I can easily identify this is the water body. Okay, suppose you want to work with the another region, which region is you did not visit physically. Okay, then you did not understand where the water, where the urban body, or where the vegetation is available. Then we also need to follow the band combination method. Okay, so we are using the different types of band combination, and different types of band combination provide you the different types of feature. Suppose in this time when I using the another band combination, you can see I use at the band 5, band 4, and band 3. So when I use this band combination in this time, I get the feature on the on from this image. Red color identify the better vegetation, black color identify the water body, and white color identify the urban. Okay, so I simply increasing the stress 98% and apply and check. See, we can see I can get the water body as a black color. Okay, then I can get also the vegetation or dense vegetation as a you can see this is the vegetation as a red, a better red pixel value. Okay, and urban feature we can get the some as a white color or brown color. Okay, so I can see I can easily identify this is the black color. So black color is identify this is the water body. Okay, so I can easily take the training point as a water body, because when you want to use this band combination, it's showing the water body as a black color. Okay, and vegetation or good vegetation showing as a red color. So you can easily identify and take the training point for this. Okay, I simply take the training point. Okay, so in this time also take the training point for the after suppose build of area or urban area. So I simply use here this another new layer, click on here, then simply click on here, then I simply put this name as suppose urban. Then I simply take this urban or build of areas, then simply click the feature collection, then property name will be same. So I simply use here the class and set the value for the urban 0. I set the value for the 1. Okay, so I simply click on here, and then you can see I select the urban, and in this time I use here the true color composite. I can take the training point for the urban or build up area. So I simply take the point. Okay, so in this time also take the training point for the vegetation. So I simply click on here and then simply click on again in here. So I simply put the name suppose, okay, and I simply put here the feature collection property will be same class and set the value 0, 1 and 2. Okay, then okay. So in this time I use at the band 5, band 4 and band 3. This is the band combination we are using for the find out the vegetation. This time when I use the band combination, the red pixel value identify the better vegetation and click to the apply. So in this time I take the training point such as the red pixel value. Okay. And finally let's take the another new layer. Suppose I simply click, I can simply use here the band length and then click on the geometry as a feature collection property class same name, set the value for C and click on the OK. So in this time I use here the another band combination, suppose 6, 5, 4. So mainly this okay, so mainly we are using this band combination for identify the barren land. Okay, barren land we can easily identify as a brown color, this type of color. When I using this band combination, it's showing the showing this the barren land or fallow land, this type of pink color, brown color. Okay, so I simply take the select the brown barren land and then so this is my third step. So I need to train which class you want to classify. You need to take the training point. The lot of way for taking the training point. Suppose if you want, you can also go to the field and take the GPS location, and you can convert the all of the GPS location into the point shape file. And this point shape file you are also using as a training point, training data set. Okay. So mainly when you want to make the crop classification, different types of crops such as rice, jute, or other sugar cane at the same time, you want to classify the different types of crops, then you can simply go to the field and calculate the some training point for the different types of crop. And after this you can simply make all of the training point shape file for individual crops and simply import the point shape file in the asset tab, and then you can simply import all of the point look like this. Okay, with for the shape file the same process you can simply import, and then you can use this all of the training point as a training data set. So in this time I take the training point for the satellite images, and then in this time my fourth step is that I need to merge all of the training point together. Okay, so you can see my fourth step is that, so merge training point, all of the training point I need to merge. Okay, so it's very easy, just I simply take a variable here. Suppose I take the variable suppose sample, and then I simply call my all of the water plus water, it merge with that the urban merge with station vegetation, it also merge with airland. Okay, because I simply merge all of the training points. So now I want to check what's the look all of training dataset or training point. So I simply use at the print and then call the sample and sample and click the run. So now I can get all of the information about this training point. Okay. So here I can get total 158 training point for all of the classes. Okay, and I click on here, you can see it will be start from the 0. 0 is the first training point. From last we can get the 157. So total 158 training point I take for all of the classes, water, urban, vegetation, and badland. So when I click on here, suppose this training point, 20 number of training point, I simply click to here. You can see the point. So what is my coordinate? I can get the coordinate, as well as when I click on here, I can get 0. So 0 means that this training point I used for water body, because you can see when I want to use the water, I set the value 0. Okay. So when you want to check the another training point, suppose 60 number of training point, what's the class it represent? Okay. So I simply click on here and click on the property. You can say I can get the class 1. So this training point is represented, the 1 means that urban. Okay. So all of the training point has also added with their class. Okay. So you can see this is the class for 3. So 3 means that barren land. Okay, so all of the training point we can easily add with their class. So in this time, I need to add some band, such as which band I want to get the pixel value or a spectral signature I want to create. So in this time, I take the some band, then all of the band for each point I get need all of the band value. Okay, so in this time, suppose I just simply take a variable. Suppose this variable name is the band. Okay, so in this time I simply use that the suppose band is that to 1. I take the b1 band pixel value, then b2, b2, then I simply use that the b3, and also use that the b4, and also use that the 5, and also that the 6, 6, that the b. Okay. So I simply take this band. Suppose in this time all of the band I want to extract the pixel value for all of the point, total 158 training point. So in this time I will not use any external band such as NDVI, NDWI, BCI, TCI, or other index I did not add. So in this time I internal band I want to use and then make the classification. If you want, you can also add here the suppose external band NDVI you can add. You can, if you want, you can also use here the NDWI. If you want, you can also add here the BI index or build up index or as a band. Okay, so in this time I will not showing this process, but you also try to add all of the band, because I already show you that how you can easily create the external band. In this time you can see when I click on here I can in this image I want to get the 17 bands. So I print this image, you can see print, yes, click to the run. 17 bands I want to get in this from this image. But if you want, and I want to use here the b1, b2, b6, 7, just I use this band. If you want, you can also add here the some external bands such as NDVI, NDWI, then also you can use here the NDCI when you want to work with any sono index or sono region. You can also use here the NDCI. So lot of external index you can easily add in here. So then you also need to make the function. I also try to show you this process. So if you also try to for your own self, and if you not do this, then I also provide you the code, no problem, how you can easily add the external in band. Okay, so in this time I can only use here the which band is already available in this image. I just put this all of the band, but if you want, you can also create the external band and also add this. Okay, then you can also get the better land use land cover classification map. So in this time I want to just extract all of the band value. So B1, B2, B3, all of the band value I want to extract for each training point. Suppose number 1 training point, this training point I want to extract all of the band value. This training point I want to extract all of the band value. This training point I want to extract all of the band value. This training point. So all of the training points I just need to extract all of the band values. Okay. So for this we are using a function. It's called the sample region function. So let's go. So in this time I simply take a variable and give the variable name is that suppose I put the variable name is the input. Okay, in this time you can see this is the total this band is not add with my image. Okay, this is my image. This image is stored total 17 bands. from the 17 bands I want to select some band and add in a list. Okay, but this bands it is not add with my image. So in this time I simply take another variable input and then call the image and then just simply paste here and use the function it's called the select function. Select and then simply copy the bands, paste here. The same things if you want, you can simply use here the select function. Select function, you can simply use here the select function and call this variable name. Same process. So in this time I take the separate variable name input and simply call my image because it will be stored all of the things. Then I simply call the select and in the list I want to add variable name bands. Okay, so in this time I just simply extract all of the band pixel value. So for this I simply take a variable. Suppose this variable name is the training. Okay, and then I just simply call this input. Okay, because this variable is stored with my image as well as also all of the band which I want to need the pixel value. So I simply call the input and paste here, and then I simply use a function. It's called the sample region function. So sample region, okay, region, sample region, and then I simply press all of the things. I can get all of the argument. I just simply fill up all of the argument using the dictionary. So I simply use here the curly bracket start as well as also curly bracket invert. Then put all of the keyword and key value one by one. So first of all, collection. So collection is that your all of the training point. Okay, this is a collection. So all of the training point I can get total 158 training point, and all of the things is stored in a variable. This variable name is a sample. I simply copy the sample and paste. Okay, then properties. So properties is that your property name. You can see in this time we are using the same property name. Okay, you can see property name is the class. Okay, I simply copy and all of the feature urban, water, vegetation, management, I use the same properties. Okay, same property name. In this time you can see this is the properties. Okay, so that's why I need to use here the square bracket and then put this property name class, because property is the I can see there the water for the class, urban for the class. So all of the properties as a list. Okay, so then that's why I simply use the square bracket and put this class, because this is the properties. Okay, it's not only for the one class. They are the total 4 class. Okay, so in this time scale. So scale is the resolution of the satellite images. It's the 30-meter resolution for the Landsat. Okay, so projection not need for this time. I simply remove it. But in this time I simply just try to show you that what the value I have to get. So I simply print this and simply call the training. And so in this time you can see I want to get this all of the training total 158 training point. In this time when I click to here and click on a suppose, you can see I can get all of the bandwidth. Suppose 0 number training point, I simply click to here and click on the property. You can see for the 0 number class I want to get all of the band value for the point number 1, training point number 1. So you can see, suppose I want to check the 26, so I can click and click, you can see properties. I can get all of the band value for the 26 number of point, and this point is represented the 0. It means that water, yeah. As well as you can check the 51. You can check. I can get all of the band pixel value for the 51 training point and get the, and this is the class 1, and class 1 means that urban. Okay, so I can get all of the band pixel value. Okay, and this is my training dataset. I use this training dataset and then make this classification map on this satellite image. Okay, so this is my step number is that okay, so this is my step. Okay, so in this time, anyone any question in this time? Anyone any question or any doubt here? Any question or any doubt? So I continue. and face any problem for any time, you can just contact in our WhatsApp group. Then I hope you can get the solution. Okay, so let's go. In this time, I want to just get all of the training point pixel value or a spectral signature. In this time, I use here the classifier and then classes and classified these satellite images. There are a lot of classifier is available in here. Okay, and all of the classifier has a lot of things. Suppose when you want to work with the support vector machine, then you also need to know what is the support vector machine, what is the argument of the support vector machine. So all of the details in this time I will not discuss about all of the things for the machine learning method. In this time I just show you that how you can easily use this. Okay, so I can easily use this function, because in this time in Google Earth Engine platform, support vector machine, classification, regression trace, as well as also minimum distance. So all of the classifier is already available in the Google Earth Engine as a built-in function. This function is already available. Just I simply call the function and then train our all of the data set and then classified this satellite images. Okay. Okay. So in this time, I just simply use the function. Suppose I simply take a variable and put the variable name such as any variable name. I simply put the variable name is suppose classifier. Okay. Classifier. The lot of classifier is available in here. I want to simply search here and then simply set the classifier. So I want to use here the classification and regression trees, this model. I just simply copy. I simply copy. And paste here. Okay. So in this time you can see I want to use here the classification and regression trees and then train my all of the data set and then classify this image. Okay. So here the max nodes, this is the integer value, and mean population is the default value is the 1. So I simply use here all of the things as the default. So I simply remove all of the argument. When you can remove all of the argument, it means that you are using as a default. With value set, you can see their default set the value. I simply open this. Default it's null and default it's 1. Okay. So in this time I simply use the default and then try to make the classification. In this time you can see this is my classifier. I will simply call this classifier. I use this classifier and then train my all of the data set. So I want simply the function, it's called the train function. Train and put all of the argument one by one. So I simply make a dictionary in here. Curly bracket start. Curly bracket. Okay, so first of all, feature. This is the keyword. And this key value is that first feature. So feature is your training data set. Okay, feature is your training data set. So just I simply copy the training and then simply paste here. Okay, training, because this it stored all of the data set. Then class property. So class property. This time we can see it's not properties. It is a class property. UI. So singular. So I simply use here the class. I don't need to use here the square bracket as a list. Okay. So then input properties, I use here the input properties such as band, all of the band. So just I simply call my band variable band, copy and paste. Other thing not needed, I simply move it. So you can see I create the classifier. In this time I create the classifier, classification and regression trees, and then train my all of the data set. Okay, so in this time this classifier I want to add with my image. Okay, so in this time I simply take the another variable. This variable name is that LULC. Then I simply, you can see my image and a specific band which I select, all of the things is stored in a variable input. I simply copy the input and then I simply paste here. Okay, and then I just simply use a function is that. In this time you can see this is my classifier. Okay, this classifier I want to add with my input. And what is the input? Input is stored at my image with a specific band which I select. In this time I want to add this classifier with my input. So I simply use a function, it's called the classify function. The classify function in this time add with my classifier with my input. Actually this is the satellite image with a specific band. So I simply copy the classifier and paste here. Okay, so now this classifier is add with my image, okay, and store it in the variable LULC. So I want to show this map, so I simply use add the map dot add layer, and then use add the LULC and click to the run. So now I can check, can get the classified image without any visualization. Can get the totally ash color map or gray color map. You can say I did not add any visualization. So in this time I want to add here the visualization and then classified the all of the feature which I want to add in here.